Hello, Algebra 1 people. Today we are going to do a little bit of a video lesson. That's just because I'm not here today, but feel free to email me if you should have any questions. The beginning of this lesson does start with a little bit of bell work. They're asking you to graph linear equations. This is what we just got done doing on our Chapter 5 test, so this should be really easy for all of you. This first one, part A, is in y equals mx plus b. So most of you guys did really, really well on the test. The y-intercept is -3. The slope would be 1. So from there, I'm going to go up 1 over 1. That'll be my next point, and then I just connect them with a line. Okay, when we take a look over here at part B, this guy is also in slope-intercept form. So as I take a look, making my little coordinate plane. Here we go. It's y equals mx plus b. My y-intercept is +2. My slope, I can see, is -1/2. So since that slope is -1/2, I'm going to go down 1 and over 2. I always run to the right, put my point, and go ahead, connect my line. This should be a very easy review for you guys. You guys can either watch the video and then do your notes, or kind of do a split screen with Notability to take notes as you're watching the video, whatever you're more comfortable with. As you look at C and D, we had 2 questions like this on our test. This is my Hoy-Vux, my special vertical and horizontal lines. So over here on part C, it's x equals in a number. There's x. I know that means it's got to be a vertical line. So when I go to draw my coordinate plane, I go to the x-axis, I go to number 3, I'm going to put a point, and I'm just going to make a vertical line. When I'm taking a look at part D, I've got y equals in a number. So I'm going to go on the y-axis down to -4. And because it's just y equals in a number, that's here. That goes with H-O-Y, Hoy. It's got to be a horizontal number. So in this case, I'm going to make a horizontal line at y equals -4. What we're going to talk about doing today is solving a system by graphing. And I believe you did something kind of like this with Mr. Dobb, where you had to solve a system of linear inequalities. This is going to be a little bit different, a little bit easier, and kind of building off of what we just learned. So we've got a lot of vocab up here. One of the things that we first talk about is a system. A system just means you have 2 or more equations. If you look at problem 1, I can see I have 1, 2 equations. That means it's a system because I have 2 of these equations. Now, a solution of a system is going to be, if I were to graph those 2 lines, where would they cross on the coordinate plane? And so we're going to take a look at that in just a moment here. So let's go ahead and jump into problem 1. It says, what is the solution of the system? Use a graph. Now, guys, with doing these with graphing, we want our graph to be pretty darn precise. So if you do want to make use of that graph paper feature, oh, you can see my line already looks pretty awful. Let me fix that. I'm going to try my best to do this really nice, really organized, because I have to see exactly where these lines are going to cross. So I want to kind of make sure my tick marks are evenly spaced. Ideally, I should be doing this on graph paper, but, you know, we're just going crazy here. So I'm going to color code this. For number 1, the first equation, y equals mx plus b. I can see that my y-intercept is 2, so I'm going to do that. I'm picking blue. I can see that my slope is going to be +1, so I'm going to go up 1 over 1. Now, class, remember one of the things we talked about is that you could make additional points, up 1 over 1. I'm going to make several points because I need to make sure that I'm going to see exactly where these 2 lines are going to cross. Now, I can also make some points on the other side. So if I start back at my y-intercept, I could go down 1, left 1. That would give me another point on the same line. So I'm going to go ahead and connect that now. I've got my first one done. I did this in blue. All right, now let's take a look at the second one. I'm going to do this one in green. I always like to color code this so I can kind of see the difference between the 2 lines. So on the second equation, my y-intercept is at -2. My slope is 3, so 3 over 1. So in this case, I'm going to go up 1, 2, 3 over 1. That's going to be the first point. We'll do it again. We're going to go up 1, 2, 3 over 1. And I can see I have a point where they are going to cross. Can you guys see this right here? This point, oh, I'll go to red. This point right there, that is going to be my solution. But we don't just say, oh, draw an arrow, there's the solution. We have to write our solution as an ordered pair, x, y. Where on the coordinate plane is that crossing? I can see it's crossing it over 2. So my x value is going to be a +2 and up 1, 2, 3, 4. So my answer is going to be 2, 4, 2, 4. Now, a way that I can check that is I can plug it back in to my original equations. One equation is y equals x plus 2. Well, take a look. Your y value is 4. Your x value is 2. Let's see. 4 equals 4. Yes. I'm going to also check it in the other equation. Y equals 3x minus 2. My y value for the answer is 4. My x value is 2. 4 equals 6 minus 2. 6 minus 2 is 4. It works out in both. That's a way you can be 100% sure that you got the right answer. All right, so let's try another one. Obviously, if we were in class together, I would do this as a you try, but since I am not there, we're going to do it together. I can see again, I have 1, 2 equations. That means this is what we call a system, 2 or more equations. We solve a system of equations by graphing both of them on a coordinate plane. Now, again, guys, I'm kind of like being crazy here by drawing my own graph. If you guys want to do this with graph paper, there's some in the back of the room, so you can go ahead and grab some. It does make it a lot easier if you're doing this on graph paper. All right, so let's take a look at number 1. I've got y equals, and let me do this for a quick second. Let me get rid of this because I want to write my equation above it. I've got y equals mx plus b. I'm going to do my first equation in blue. So my y-intercept is +4. 1, 2, 3, 4. Put a point right there. My slope is +2. So from that point, I'm going to go up 2 over 1. That'll be another point right there. And let me add in a tick mark here because we can go up a few more. Hold on, let me make this a little bit higher. There we go. So I'll do it again. I'm going to go up 2 and over 1. So that could be a no. Oh, go to red, red, red. There we go. Now, like we talked about on the other one, instead of just continuing to go up 2, right 1, we can reverse that. So now what I'm going to do is I'm going to go down 2, left 1. We're just going in the opposite order. So this will be my other point right here. And I'll do it again. We want to get a good range of points because remember our job, down 2, left 1, is to see where these 2 lines are going to cross. So I think I'm pretty good. I got, if you think about it, from my y-intercept, I've got 2 points to the right of it, 2 points to the left. So I'll go ahead and connect my points to make my line. And let's go ahead and plot the second equation. I'll go in green, so we have some nice little holiday colors for you guys. My y-intercept is at +2, and my slope is going to be 1. So from that ordered pair, 1, or 2, sorry, I'm going to go up 1, right 1. Put a point there. We can do it again. Remember, we want to get a good range of points, so up 1, right 1. Now, one of the things I'm noticing, I'm going to do it one more time, is as I continue to move in this direction, I am getting further away. Like if I keep going this way, I'm not going to cross that red line. So that's a clue in my brain that, hey, wait a minute, let's try to move in the other direction. So I'm going to go back to my y-intercept, and now I'm going to reverse it. I'm going to go down 1, right 1. I'll put a point right there, and we'll do it again. We'll go down 1, right 1. And bada bing, we got it. That is where they're going to cross. I'll draw my line so I can clearly see where they cross. This is going to represent my solution. But remember, guys, we're not going to just be like, oh, cool, there's the solution, we found it. No, we have to write that solution as an ordered pair. We've got to have x comma y. So I have to figure out where that is. Here's my x-axis, here's my y-axis. To get the coordinates of that ordered pair, I start at the origin, and I am moving 1, 2 to the left. Since I'm going 2 to the left, that's going to be a -2. My y value, I'm not going up or down any. I'm right there on the axis. So my y value is going to be 0. That's going to be my solution. And guys, remember, we can always check this. I'll go back to the original equations. This is the first equation. Where I see y, I'll plug in 0. Where I see x, I'm going to plug in -2. Simplify this. 2 times -2 is -4. -4 and 4 is 0. That balances out. That's good. We also want to take some time to check it in the other equation. Y equals x plus 2. Remember, y is 0, x is -2. I'm plugging in the values of my solution. This also balances. That's a way that I am 100% sure I have this correct. All right, guys, so we're going to take a look at some special cases. So far, everything that we have done has looked like this. We had 2 lines, we graphed them, and they intersected at one place. We had one solution, and we call this a independent system, okay? One solution. This is probably going to happen the majority of the time, but we also have a couple of special cases. So taking a look over here, these are, and I am going to write this up here, just some special cases that can occur. So if you look at this one, infinitely many solutions, you notice how that line is purple? Well, think back when you were younger and you were maybe in preschool or elementary school. If you mixed red and blue together, guess what you get? You get purple. So what they're showing me here is that the lines are the exact same. You're looking at a red line right on top of a blue line, or maybe the other way around, a blue line on top of a red line. In this case, the lines have the same slope and the y-intercept. I always think about this like you're going to have the same exact equation. If you have the exact same equation, you're going to get the exact same line. And what happens is that means you have like a blue point everywhere on this line, because this is the blue line. You also have a red point everywhere on that line. The points are crossing everywhere, and that's why we say infinitely many solutions. This one is considered a dependent system. All right, last case, guys, is going to be if we have no solution. No solution, if you look here at the red and the blue line, these are never going to cross. They're never going to intersect. That's because these lines are parallel. So parallel lines have the same slopes and different y-intercepts. In this case, guys, these are considered inconsistent. The biggest thing that we need to remember is that these parallel lines have the exact same slope. That's why they don't ever cross. So let's practice that, our special cases. It says systems with infinitely many solutions or no solutions. What is the solution of each system? And notice it's saying use a graph. So kind of like what we did at the beginning. Now, as I look at part A, I can see, okay, yeah, that is a system. I've got 1, 2 equations. Remember, guys, anytime we have 2 or more equations, that's a system. Now, when I look at number 1, I'm going to do like a little frowny face there. I don't like that because that equation is not in slope-intercept form. It's actually in standard form. So you could graph it with the intercepts, or I'm going to do it this way. I'm going to take that equation number 1 over here where I have some room, and I'm going to try to solve this for y. I'm going to try to get that y by itself so I can put it in slope-intercept form. So I'm going to add x to both sides. That'll get me 2y equals x plus 2. And as my last step, again, I'm trying to get this y all by itself. I'm going to go ahead and divide everything by 2. So that'll get me y equals, now I'm remembering there's a 1 in front of that x, 1 over 2x plus 2 over 2, that's going to reduce to 1. So now I'm going to give this guy a little smiley face. It's a lot easier. That's in slope-intercept form, so we know how to do that. All right, I'm carefully going to draw my coordinate plane. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm just making my tick marks, guys. I'm going to go ahead and I'm going to do my first one in red so I can see that my y-intercept, if I'm y equals mx plus b, is at positive 1. My slope is 1 over 2. Up 1 over 2. We can put a point there. Remember, guys, we always can do it again. Up 1 over 2. And we can reverse our order. We can go from the y-intercept down 1 over 2. Just gives us a range of points. I'll go ahead and connect that to make my line. And now I'm going to graph the second one. I'll do the second one in blue. All right, look, I can see the y-intercept is at 1. I can see my slope is 1 over 2. So I'm going to go up 1 over 2. We'll put a point there. We can do it again. Up 1 over 2. Hey, you know what I'm noticing? This is the exact same line. If I actually had purple, I could maybe do this in another color, but I don't think I have purple on this. So this is the exact same line. When that happens, they are crossing or intersecting everywhere. This means I have infinitely many solutions. And that is your answer. You're not writing an ordered pair. There's too many ordered pairs. It's every single place. So your answer is just infinitely many solutions. Let's take a look at part B. So I'm happy on part B. They're both in y equals mx plus b, so that's nice. We'll go ahead and make a coordinate plane. And just like I did before, I'm going to color code it. So let's do the first one in red. I've got y equals mx plus b. My y-intercept is at positive 2. My slope is positive 2. So we will go up 2 over 1. Can do it again. I guess I need another little tick mark here. Hold on. All right, sorry guys. So here we go. We'll go up 2 over 1. And kind of like what we talked about, we can go ahead and grab some points on the other side. Down to right 1. And maybe I'll do it one more time just so we get good practice at going both ways. All right, let's connect that line. That's my first line. And since it's a system, we know we have another one. I'm going to do the second one in blue. I always like to color code this so it's nice and easy for me to see. In the second equation, my y-intercept is at negative 1, and my slope is positive 2. So I am going to be traveling from this point up 2 over 1. Put my point there. We'll do it again. Up 2 over 1. All right. Let's take a look at going the other way. So I'm back to the y-intercept, down to left 1, and put a point there. And I can try one more time. Down to left 1. All right, let's connect that. I can see that these lines, they do not cross. The reason they don't cross is they're parallel, right? They have the exact same slope. Now, I really could have noticed that at the beginning, but I wanted you guys to do the work. Both slopes are the same, so same slope. But look at this, different y-intercepts. That's how you know that they're going to be parallel. So in this case, my answer, actually what I would write for my answer is no solution. All right, so last thing, we're going to just try these again. If we were in class, these would be you tries. And I want to show you this really quick. As I look at part A, obviously it's a system. We've got we've got 2 graphs. I'm very happy. They're both in slope-intercept form. I can honestly, guys, tell right now that these 2 lines are going to be parallel. I don't know if you guys can also see it, because look at that. They have the exact same slopes. They both have a slope of -1, But I also can look at over here, they have different y-intercepts. So I know these are going to be parallel, which means they're never going to cross, so we'll have no solution. So you can kind of think a little bit smarter. If you get, more practice with this and recognize it, then it makes it a little bit easier to figure out our answer. However, this question did ask me to go ahead and do a graph, so let's just take a moment and do that. By now, we should be experts at graphing in slope-intercept form. So I'm going to just make my little coordinate plane. I'm going to do my first one in red. So in the first equation, my y-intercept is at -3. My slope is -1. So down 1, I want to do that in red, down 1, right 1. We'll put a point there. We'll do it again, down 1, right 1. And of course, we can reverse that order. We can go up 1, left 1 to get a point on that side. And we'll do it one more time just because why not, right? We like graphing. All right, so let's connect those. Ooh, I didn't connect it very good. Sorry, guys. And then we'll take a look at graph number 2. In this one, my y-intercept is +5. So I'll put a point at 5 on the y-intercept, or y-axis, I'm sorry. And my slope is -1. So I'm going to go down 1, right 1. And we can do this again. Down 1, right 1. You can get some on the other side, so up 1, left 1. And do it again if you'd like, up 1, left 1. And as you go to connect these, that's where it's very clear that you can see these do not intersect. So I'm going to say no solution. That is the answer. Okay, last one over here, part B. Part B, okay, number 1 gets a smiley because that's in slope-intercept. Number 2, that gets a frown because that's in not slope-intercept. So what we'll do is I'm going to go ahead and just make my coordinate plane really quick off to the side. 1, 2, 3, 4, 5, maybe a little bit more. 3, 4, 5, 2, 2, 2, 2, 2. Okay, let's go ahead and graph number 1. We'll get this done. We'll do this in red. So my y-intercept is at -3. My slope is +3. So I'm going to go up 1, 2, 3, and over 1. And again, up 1, 2, 3, and over 1. We can go the opposite way, down 1, 2, 3, and over 1. And I'm kind of going to stop there. So I'll go ahead and make that. We got the first line done. Now we need to do the second line. So what I'm going to do first is I'm going to go ahead and I'm going to do this in blue. I want to get that y by itself. So I'm going to divide everything by 3. So I get 3x minus 3. Now we change to a smiley face. We're in slope-intercept. But class, pay attention and look. Before I even plot that, I'm going to look at these equations. Look at this equation that we just got compared to the first one. It's very crystal clear to see that these are the exact same equations. If it's the exact same equation, that's going to produce the exact same line. Think about it. If I go to graph number 2, my y-intercept is -3. My slope is +3. I'm going to go up 3 over 1. Guys, this is exactly the same line. It's the exact same equation. That means this would technically turn to purple, right? Blue and red together. This is going to be infinitely many solutions. They literally cross everywhere. Okay? Guys, that is it for our lesson. The practice is in Canvas, so it's a 6-1 practice in Canvas. It's 8 questions. The graphs are provided, so you won't need to be making any coordinate planes on your own. I want you to work on that. Look back to the lesson if you need help, and you can, of course, always email me. If you wanted to retake that Chapter 5 test, don't forget you need to work on your corrections, okay? And the Chapter 5 retakes are going to be on our block day, Wednesday or Thursday. All right, guys, email me with any questions. I hope you have a great day.